Wind streams are the invisible currents of air that flow across the earth, carrying the breath of life and the seeds of change. They're shaped by the forces of nature, such as the spinning of the planet, the heating of the sun, and the pressure of the atmosphere. They can affect everything from the weather to the climate, from the flight of birds to the movement of planes, from the spread of pollution to the quality of air. So mapping wind streams is useful for many reasons, such as understanding how the wind affects our lives, predicting what the weather will be like, planning how to travel by air, monitoring how clean or dirty the air is, and studying how the climate is changing. By using powerful computers and satellites, scientists can create amazing wind maps and other conditions that show how the air moves and changes around the world. So in today's tutorial, we'll be using wind data from the European Center for Medium Range Weather Forecast to create a powerful and useful wind map of Europe. Hello people, this is Milos. Welcome back to my channel as I take you on another data visualization and geospatial journey with R. This time we're going to be creating beautiful and effective wind streamline maps using several very cool packages. First of all, I'm going to show you how you can load the data from the climate data store directly into R by building a request within R. Then once we get the data, I will show you how you can build wind speed based on the U and V components of wind. And finally, we're going to be using awesome metR library to create a beautiful streamlined wind map of Europe in ggplot2. Alright guys, let's kick off our adventure by first of all installing and then loading the packages that we need for this session. The first one that we will need is the ECMWFR package, which has a bit of a strange name. This is actually an acronym for the European Center for Medium Range Weather Forecast that is actually hosting the data on winds, among other data, climate data. So that's the first one that we will be using in this tutorial. So I'm going to here create a list of libraries that we want to need and then start defining them. So the first one is ECMWFR. The second one that we need is the Tidyverse, which is an umbrella package for data wrangling and data visualization. There's several of them that we're going to use, most importantly dplyr and tidyr for data wrangling and ggplot2 for data visualization. Now there's an additional package that we'll be using within ggplot2 to specifically create wind streamlines, and that one is called metR. It's a very cool package and it gives an additional functionality to ggplot2 that doesn't exist in the original package. Because after we load or download the wind data, it's going to be in a raster format. In order for us to load it into R, we definitely need to use Terra for that. We also are going to be creating a wind map of Europe, and for that purpose, we should load the shapefiles and work with shapefiles. So for that, we'll be using the SF package. And in order to get the national boundaries of Europe, we'll be using gsco.r, which communicates, so it's a client package to communicate with gsco. And then finally, we'll also be defining breaks, and for that, I use the class int package. All right, so these are the libraries that we need, but we don't have all of them, and we're going to check in a minute what are those that we have. So we're going to create an object called installed libs, and then we're going to check within the row names of the installed packages, what are those that exist within that libs. So installed packages. If they're not installed, we need to write an if-else statement. So if any of these installed libs equal false, then in that case, we are going to open these curly brackets and we're going to tell R to install them. So in that case, we're going to say install packages. But we don't need all the packages, we need libs, and specifically, we need those that are not among installed libs. All right, so after we have this, after we install the packages we need, we can finally load them into R, and to load them into R is pretty straightforward. So we just need to apply the library arguments to that libs list that we already have. And this is actually how you do it in R. All right, so in this tutorial, we'll be using this ECMWF package to access the Climate Change Services Climate Data Store. And for that purpose, you need to go to this website. So cds.climate.copernicus.eu. It will take you to this main page where you need to go to this upper right corner where it says login register. Click there, and once you click, it's going to take you to the page where you can create a new account. So click on this tab, create new account. And over there, you need to fill out certain details. So email, first, last name, country, sector, not so important, I think. But you can also check it out, what is needed. But what is very important is that you click on these terms of services. So you check them. And then in the end, you put this code and then click on create new account. So create new account, click on this one. And after you create that, you will get a confirmation email. And just by following that, you will be able to activate your account. And once you activate your accounts, you will be able to see two things. One of them is your user ID name, and the other one is your IPI key. So these two are necessary for you to then actually access this data, which we're going to do in R. All right, hopefully you managed to register at the CDS website. If you're still not sure how to register, you can take a look at one of my previous tutorials where I walk you through the process in detail. All right, but if you did manage, we're going to go back now in R, and you need to, again, copy two things from your newly created profile. One is your UID. Basically, this is a 5-integer unique identifier of your profile. And then the second one just below that is a combination of characters and numbers, and this is your API key. So what I would like you to do next is, once you have those two, please insert your UID instead of these asterisks in the first one. So my API is going to be your UID. Insert here. It needs to be in the form of a string. So you need to wrap them inside the quotes, just as I put this asterisk. And then do the same for your API key in this my key equals to, etc., etc. All right. Once you do that, then we can use that package to fetch the wind data. Now, the thing or like a note of caution about this package is that there's a latency of 4 to 5 days. So I'm filming this on 4th of August, and I can tell you that the data is available, the latest one, for 29th of July. So this is what we're going to do. We're going to take the data for the 29th of July, and we're going to take the data for every hour of 29th of July, and then we're going to average it. The reason why we're doing that is you can, of course, take a random hour on the 29th of July, but that does not represent the whole day. So it's way better to actually take for different hours and then average, because then you have more or less approximate picture of what was happening on 29th of July. That's the first thing. The second thing is we will be creating a wind map of Europe. So we'll be taking this for the area of Europe. But once we get to that part, the first thing is to create a range of times here. So from 00 hours to 23 hours of 29th of July. For that, we can use package lubridate. If you didn't install package lubridate, if you don't have it, you can simply write here, install packages and then lubridate, and then just call it here library lubridate, just like this. All right, once we have this, we can create a new object, which is going to be called time. Time is going to be the list of hours. So as I said, from 00 to 23, so that we capture every hour of the 29th of July. So here we're going to create a sequence. Sequence is going to go from, to, and then it needs to have also by. So it needs to have some kind of a separator. And because we want every hour, it's going to be by 1 hours. Okay, then within this from, we need to actually use lubridate package. So we're going to use here lubridate, and there is a very convenient function which is create timestamp for you. So that one is called ymd_HMS. Essentially, what this is going to do for you is it's going to create date plus time. But in the rest of the code, we're just going to get rid of the date, and we're just going to have hours, minutes, and seconds. So first of all, you need to here declare your year, so 2023, then your month. So we're taking July, then your date, 29th, and then we're starting from the beginning of 29th of July. So that means 0 hours, 0 minutes, and 0 seconds. And most importantly here, once you're done with this, you need to separate these by dash. All right, and then wrap this up into paste, because you want to create here a single date. So that's it. That's how you do it. Now we can simply copy this whole chunk into this part, which is called 2, and then replace here only one thing, which is this 00 hours with 23. Essentially, we will create from 0 to 23 hours, and I'm going to show you in a bit how that actually looks like. So that's the first part. Now that we actually have time, we can just simply run this, and after running, we can actually print time so that I can show you what actually we have here. So this is what we have. So we have time for every hour of 29th of July. This is what we're gonna then next this is what we're gonna cut next. And there is another cool package that you can also install here, and that will help you with that. It's called HMS. Unless it goes with Lubricate, I didn't check. If it doesn't, you can just install it here, and also you can call it here library HMS. Now, what does this package do for us? This package is going to take this time that we created, and it's going to get rid of the dates part. So we're going to create here an object called hours, and then we're going to use from HMS, there is a function called as HMS. What this is essentially going to do is what we just described. So it's just going to get rid of all those dates that we don't need anymore. And I'm going to show you in a bit how this looks like. So we run this, and then bam, we got hours. So we got here, as you can see, we got from 00 to 23 hours. Our next task is to get the area coordinates for which we want to download the wind data. You see, in order to use the package for downloading wind data, we need to define the bounding box, which is the minimum and maximum longitude and latitude values. So I went to this website, which I often do. It's called bboxfinder.com. And then I selected the area of Europe that I found that for which I would like to download the data. And then you can see there in the link, it's going to show you the actual coordinates. So what you can do is you can select these coordinates, copy them, and next thing, we're going to take them back to R and use them to define our area of interest. All right, back in R, we actually copied and pasted now these coordinates that we got. So I'm going to create now objects for each of them. So let's start with the minimum latitude, which is this 32, and I'm just going to round them to a single digit, so 32. Then the next one is the minimum longitude, denoted by xmin, which is the next one, so minus 25. Then we have the maximum latitude, so ymax, so that's 72. And then finally we have the xmax, which is 48. Okay, now we are ready to build the request. So we need to build a request, and we need to send to this website, CDS, in order to get the wind data. And the question is how we build a request and what are the elements of the request, which we're going to see in a bit. But this is the place where we can find the answer. So this is where you also went before to register your account, if you remember. If you scroll down, there is this box where you can search the data sets, and we're going to search for Era 5 climates, and just click here on search button, which is going to open a lot of results. But we need only one, which is called Era 5 hourly data on single levels from 1940 to present. So you just click here, and this will take you actually to the description of this dataset, which is the atmospheric reanalysis dataset, and which actually has information on wind that we are seeking. So there are other things here that you can also notice. So yeah, it's on a regular grid, it's hourly data from 1940 to present, and it's a reanalysis with a very, very high resolution. So if you go down there to the main variables box, there are two components that we need here. One is the so-called U component of wind, and another one is this 10 meters V component of wind. Both are the components that are used to measure the speed and direction. So without these two, we are not able to do that. But what are these? So they are both horizontal speeds of air, but the U component is the horizontal speed of air moving towards the east at the height of 10 meters above the surface. That's why we have this 10 meters here. While the 10 meters V component is the northward component of the 10 meters wind. So it's the horizontal speed of air moving towards the north. Again, measured at a height of 10 meters above the surface. So with these two measures, we will be able to measure the speed and the direction of the wind. So we need these two to download. Anyways, you go back to this top of this page, and there is this tab called download data. We click here, and here is where we can build the query. So we need two components, as we said. We need this 10mu component, 10metRD component. For the year, we need 2023, we need July, and we're gonna go for the 29th of July, and here for every day or every hour of 29th of July. So here we would need a specific region, but that's not the point. So the point I wanna make here is, I wanna here show you the API request. And why am I doing this? I'm doing this because I want you to understand the structure of this request that we will now create in R itself. So there are several things here to understand. First of all, so this is the name of the dataset is reanalysis-era-single-levels. Then the product type is reanalysis. We will be getting this in the nets CDF format. And then the two variables, I think this is even the most important part. These are the names of the variables that we're going to be fetching through that client library in R. And then finally, this is the, just simply the time. So year, month, day, and time. Okay, let's build that request. We're just gonna call it simply request here. And request is a list. You remember there were a list of items on that CDS website, so we need to treat it as a list. The first one is, if you remember, product type. And it's exactly like over there, product_type, and it's reanalysis. So that's the name of the product, reanalysis. Then we need to put comma here and to add another member of the list, because this is how you add new list members in R. The second one is formats. So as we said, we're going to use net CDF. And one thing you also might notice here, you're using here strings. So this is how you need to define, even when we come to the date part. So that's the format. Then the third one, if you remember, it's a variable. Variable, we're going to have two variables, and that's why I'm using here C, because C is the list in R. There are two variables. Both are 10 meters, but one is the U component. You could have also, for example, copied this and just pasted it into R. I'm just making my life more difficult, as I sometimes do. But in this case, it's actually pretty straightforward. So 10 meters U component, and then 10 meters V component of wind. So those are the two elements that we need. Next part in this request that we're building is year. So again, you're going to put this into quotes. So 2023. Month, as we said, we're going to take the 7th month, so that's July, and then the day is 29th of July. Now here we said we want to take the hours for the entire day. Luckily for us, we defined that, so time equals hours. We already have that. And the area, so area, as we said, we already have, but now there is a tricky part which I wanted to bring to your attention. Usually when you define area for this client request, you actually go with X minimum and then maybe Y minimum and then X maximum. So in the case of the CDS, it's a bit tumble around. So it goes like this. You go first for Y max, so maximum latitude, and then you go for the minimum longitude, and then you go for the minimum latitude, and you wrap up everything with the maximum longitude, so X max. So this is also the reason why I defined previously those coordinates for the bounding box, because I wanted you to see here what is the order, so that next time you actually do your stuff, put your coordinates, you know what is the order. Anyways, so this is almost there. Two last things. One is the dataset short name. I mean, it sounds like a short name, but it's actually long. And I also brought your attention to that one. So it's called reanalysis, and then dash era 5, and then dash single, and then dash levels. So that's the name of it. And then the final one is, this is going to download the netCDF file to your local drive. So here you need to say what is going to be the target name of your file. So I'm going to call this Europe wind and then .nc. All right, so once you build this request, the next thing is you need to register your key with the service, your user ID and your API key. So for that, finally, we're going to call the ECMWFR library, and we're going to use a function from this library, which is called WFSetKey. And over here, we're going to define three things. First of all, user. We already defined user within this my API. Then key is going to be my key. So we also define that one. And finally, the service that we want to access is, of course, CDS. All right, and once you run this, you should be able to see that your user and the number for CDS service was successfully added to the keychain. And then once it's added to the keychain, you can now simply use this to request the data from the server. And to request the data from the server, once again, we're going to use also this library, ECMWFR, but this time we're going to use WF request. And then within this request, we're going to say request equals, well, request that we just made, that we built before. Second one is, again, you need to define here the user. So again, it's called my API, which you already stored. And then finally, what is going to be the pathway here? So let's actually say that we're just going to save this in my working directory, right? So once you actually, once you start this, the service will then, the request will be sent to the service. The service will then see if the request is valid. In other words, your username, your API key, do they correspond to what you declared? Do they even exist? And after that, it's going to return you for that area. Once we have the data, we can simply load it into R using Terra package. And I'm going to call this one Europe_wins. Terra, we can use function Rust, which is going to load it. We just need to declare what is the name. Well, we already have the name, so it's called Europe and then -wins.nc, very important. So this will actually load the data, and let's actually do that right away. I just want to show you what this looks like. So if I inspect this file, I'm going to see several things here. Of course, class is path raster because we're working with Terra. This is the resolution, so 0.25 times 25. These are the dimensions of the bounding box, and the reference system is WGS84, which we're not going to change. Now, there are actually two sources, 24 layers in total, which means 12 hours plus 12 hours. Now, you might be wondering why. Here is the answer. The answer is because we have two layers. One is for the U component, because that's the first variable, and the second one is for the V component of the wind. So that's the second one. So it's also here. So var names or variable names, U10 and V10. Now you will notice something here in terms of the names of the layers. We said we have 24. You will notice that instead of dates as the names of the layers, we have this weird name. So U10 and then _1. Well, this is simply in the order of appearance. So this one is basically just 00 hours of 29th of July. The next one is the first hour, second hour, etc., etc. The thing is, what we have here is a mishmash of U10 and V10. What we want to do is separate them. We want to separate them, and then at the end we want to put them together. But we cannot hold them like this because we also need to average the values for the U component and the V component, and that we need to do separately. So the next thing I want to show you is how you can actually achieve that. And to achieve that, first of all, we need to convert this Europe wind into a data frame. So I'm just going to create this Europe wind df, and then I'm just going to put this Europe wind raster into a pipe, and here use as data frame to convert this into a data frame. So first of all, I'm saying here what I'm going to do actually. Every cell, I'm going to create a centroid. This is exactly what I'm doing here. So that means that I want to coordinates of every centroid cell to be returned. That means in this data frame, I'm definitely going to have X and Y, where X is a longitude and Y is the latitude of that centroid. And finally, I'm here going to put that I want to remove the values, which are NA values. So let me actually show you what I mean by this. Let's actually just inspect the first few rows of this newly created data frame so that you understand what happened after we transformed that raster into a data frame. So this is what happened. We have now a bunch of columns. So we have here, of course, X and Y, but we also have for U and V components. Now every layer has become a column with its name. So we got a white format. What we actually want, first of all, we want to separate U and V values, but keep the coordinates in each of them. And second, we want to transform each of these white formats into a long format, in a sense where we will have a new column, which is going to indicate, what is that, a specific U layer date. And the second column which is gonna indicate what is the U or V value depending on data frame. So this is what we're gonna do next. All right, now that we transform the win data into a DF or data frame with the XY coordinates and also values for each of the layers of the U and V components, the next thing is to extract U and V component columns and then to average them so that we get average U and V values for the 29th of July based on every hour of 29th of July. So let's create first of all a data frame for the U component. Here we're going to be working on the Europe wind DF. And now here we need to select the fields that we want. So of course we want the coordinates, so X and Y are going to be there. But then the question is, how do we select only columns which are related to this U component? Luckily for us, dplyr has an answer, and it's called start with function. Well, this function is based on the string that you provide. It's going to only give you columns that have that string. So in this case, it's going to give you based on the string with which the column starts with. So we know that a U component column starts with U. So we're just going to say, starts with U. And here I'm just going to quickly run this, and I want to show you actually what happens if I inspect the first few rows of this one. So I'm just going to quickly do that for you. So here is what happens. As you can see here, we have X and Y, that's fine. But we only have those columns that start with U, and this is exactly what we wanted. So we are then fine or good to go. The next step is to actually pivot this table. As we said, we're not happy with that wide format. We want to convert it into a long format. And for that, we can use tidyr, which comes from tidyverse. And then it has an option called pivot longer. So first of all, what I don't want to pivot here, I want those values to be fixed, are X and Y values. So that's why I'm putting here exclamation mark, which in R means exclude. So don't take them into account. So I'm saying don't take X and Y. But what do I want to change? I want to shift all those columns. And the first question is, how are you going to name the column which denotes the name of the previous column in that wide format? So that's called names2. And I'm just going to call them, let's say, time, because they do denote time. The second one is, how are you going to call the value which is going to store the values from those different columns, but now in only a single column? Well, I want this to be called U10, so I know what I'm dealing with. So, okay, once again, we can run this whole thing. And then I want to again show you what happens if we inspect now this data frame. So you see now what we get is X and Y. You see that those column names were now pivoted into a single column. So we now have U10 underscore 1 underscore 2 underscore 3. And then we also pivoted the values from those multiple columns into a single column, which is now called U10. So that's perfect. That's exactly what we need. Now, the thing is, we want in this step to average those values. So the next step is to use dplyr to first of all group by. So in our case, we want to group by X and Y. So this is what we're also going to declare here, X and Y. But in dplyr, there is additional thing that you need to do is, if you have more than one column that you want to group by, you need to say here dot groups. And what by default dplyr does, it drops the second one. I don't know why, but if you want to keep both to be your grouping columns, you need to say here keep. Okay. And once you do that, we go with the pipe and use dplyr again to now summarize values. As we said, we want average U values. So here in summarize, we create a new column which is going to be called U and say mean U10. Okay, so this is already quite a lot of codes, and I would like to run this once more and then show you the new output that we just created. So I'm just going to quickly expand this and show you the first few rows. So here now what you can see is we have X and Y, we have these groups keep that we just declared, and then now we have average U value for each of the coordinates. So X and Y. You can notice now we don't have anymore that time column. We got rid of it in this aggregation process. Okay, so there are a few more things that you can do, but you don't need to do. I will do them nevertheless, which is I want to rename X and Y and I want to name them as lon and lat so that I know I'm working longitude and latitude. So you can, for that, use a rename from dplyr, and with rename, it's a bit different. So first of all, you put the name that you want to use, and second, you put the current name. So I want to replace x with lon, and then the second one, I want to put lat in place of. So those are the things that I want. And then the final step that we can do is we can select only those columns that we need. So we're going to use select from dplyr. So we need lon, lat, and finally u. All right. And this chunk has got very long, but that's the end of it. So I'm just going to run this now, the whole thing. And once I run, I once more want to show you, the final output of this u component. And this is it. So we have lon, lat, and then we have the average u component. Now the good thing is that for the v component, we need to do basically everything that we did here, except that instead of u, we're just going to put v. So I'm simply gonna copy and paste this code here, and then just go ahead and replace every u with v. So and after we do that, we can just run this code, and after we run, we can also check, what we got. So we ran, and then now if we inspect also this few rows, you will see that we again have longitude, latitude, and then the v component of the wind. All right, in the final data wrangling stage, we simply need to merge the u and the v component on wind in order to be able to plot wind streamlines. And this is very easy. So here, I'm just going to create here a new object, which is going to be called, let's say, Europe wind stream. And then I'm going to use inner join from dplyr. So here I want to join u and v data frames. And then here I also need to define what are the fields by which I want to merge them, because they share the longitude and latitude. So basically the same points, just different, u and v values. I'm going to put here lon and lat. And because dplyr using this can issue like a warning because these are many-to-many relationships. So you can, if you want, this is optional, you can just put here relationship is many-to-many, because this is going to then, just suppress this. And then finally, in order for us to work easily with these tables, I'm just gonna transform this into a table once. As we mentioned at the beginning, we're building here a wind map of Europe, so we need to get also the national boundaries of Europe so that we know where those wind streamlines are actually located. And for that, we're going to just write a new function, which is going to be called getEuropeSF. And within this function, we'll be calling gisco_r. So we're going to create EuropeSF object. gisco_r is the client which communicates with one of the Eurostat services for fetching shapefiles of any country in the world. For this purpose, we're going to be getting European countries and some Asian countries as well. Gisco get countries is the actual function that you need. So here, what actually you want to say is what is the region for what you want to fetch, because I don't want that area of, that goes beyond Europe to be empty. Because the streamlines are also going to be over that area. I am going to here include both Europe and Asia, and then we're going to cut off using those bounding box values. We're going to cut off the rest of the map. Anyways, the third part, or the second part here that you can also define, is resolution. So this is how crisp your map is going to be. If you say 1 here, it's going to be quite crisp. So I'm just going to go for, let's say, 3. And then here we can just return this newly created object EuropeSF. And we can also call this newly created function, which is going to create this shapefile for us. One last step that I want to take before we jump on to mapping wind streamlines is to create breaks for wind speed. But in order to create wind speed, we need to use those u and v component values that we have. And there is a formula for calculating wind speed based on those two. And this formula is the following. So it's square roots of the squares of u and v components. So the way you actually write here square is the following. So it needs to have this hat, and then 2, and then goes plus, and then V also had 2. This is the formula that you need to use to create speed. Now let's put this into a context. So as we said before, so our newly created object is Europe wind stream. This is where we store those average U and V components. So then we simply need to here add them. We already have those columns U and V. We just need to attach them to this data frame, and this is how you do it using this $sign as usual. And we're going to create a new object which is going to be called speed, and that's it. So this is how you create speed. So we can simply run this, and after that we can go ahead and create breaks based on these values. So this is how we're going to do. We're going to be using the class int package for that. So we're going to call class int here, and there is an option which is called class intervals from this package. So one thing that I want to do with this package is I want to create equal breaks so that when we have the legends, that the numbers on the legend are distributed, from the beginning to the end in more or less equal way. So we're here going to do Europe wind stream, and then we're going to use speed, and based on this speed, we're going to be creating these breaks. Now I'm going to tell class int to create 6 breaks. It doesn't mean that it's going to necessarily create 6. It's going to depend on distribution of your data. And then style, because as I said, I want to have equal breaks. I'm just going to here use the equal style. One last thing here is this is going to create the list of breaks. So here I'm just going to say, give me breaks under this name. And then before all this, we can just name this newly created object breaks. And the moment you've been waiting for has come. We are ready to create our wind streamlines map of Europe in ggplot2. So first of all, we're going to call ggplot2, and we're going to here define our data. So the data we're going to be using, again, it's Europe wind stream. Then we're going to add our first layer, which is the national boundaries of Europe. So for that, we need to use geom_sf, given the fact that the object itself is the SF, or simple features object. So here we say that the data equals to Europe SF. We want this one to be transparent completely, so there is not going to be any fill or filling value, but we can color the national boundaries, and I would like to keep them in a bit of a, let's say, lighter color. So that's why I choose here light gray, because I want to create a map where the background is actually dark background. I can choose a bit thicker, let's say borders 0.25. Here you can play with this as well. And I do want these borders to be completely visible, so I'm just going to go for alpha value of 0.99. Then we can add our second layer. And here we use metR library, which is a fantastic library, which will help us create these streamlines in ggplot2. And it's going to help us do that using this geom streamline function. So here, because this is our key layer, we want to pass statics to it, which is the way in ggplot2 to say this is going to be the one that is going to have different values depending on the variables that you want to define. And some of the variables are the following. So for the x value, we want to pass ln. For y, we want to pass lat. So this is simply defining the coordinates of the wind streams. The second one is called dx. So basically, this is going to be defining the east-west displacements of the air. So that means u components. And then there is also vy, which is the v components. Now, you may have previously noticed the way we actually calculated speed. So here we're just going to pass that formula, and then we're going to wrap it up in a way that is going to allow us to calculate this for any grouping that we have. So I actually want to pass this to 3 components. One is going to be the color, and this is going to be our main one. So depending on the color, we're going to have, different speeds are going to have different colors, right? Second, I want to accentuate those wind streamlines that are the fastest. So I'm going to give more transparency to the wind that is not so fast, so that's slower. And the final one is the thickness of the lines themselves. I want to give a bit more thickness to those streamlines that are faster. So that's why I'm using here line width. Now we can just simply pass that formula that we previously created. So this is the one with some changes. So the first change is the following. Here we can simply pass this dx value instead of writing here u. And this is the way you can do that. So you need to do this dots and then dx and then dot and then head 2. This is the way to define that. And then we also need to do the same for the v component. So simply change here x to y. Okay, it's as simple as that. And now we can just simply copy this to the alpha and the line width because we want these also to be dependent on the speed. Now, this is not everything. So this is simply the aesthetics part, but this geom streamlines has a lot of other options for customization that we can enter. One of them is, for example, what is going to be the length of your lines? And for that, you can set L here. I like to set L to 2. I found it to be the most suiting one or suitable. If you choose, like a higher value here, I think streamlines become too long. If you go for shorter, maybe it's going to be better. You can also specify the resolution, so how crisp this is going to be. And here, I think the default one is 2, but I'm going to go for 10. If you find this too slow, so you cannot save your image, go ahead and choose a lower version, lower number here. Here you can also choose the number of the points that will be passed to create the streamlines. I go for 60. So the higher the number, I would say the crisper those streams are going to look like on your map. And then here, I would like those streams to be without arrows, and I can also customize that. You can say here arrow equals null, but then you can also say how, if it's not going to be the arrow on the end, how is it going to look like? And this one is controlled by this argument line end. I say I'm just going to have round at the end. So basically, I'm just going to have really streamlines without anything else. And then finally here, I'm just going to say I'm not going to inherit anything from the main aesthetics. So this was quite long, but it was useful because you also learned more about this geom streamline function. The next thing we can do is we can customize the color, the transparency, and the thickness of these streamlines. So let's start with the color. So we can use scale, color, gradients, and for that. And here we need to define, several things. One of them is, for example, what is going to be the name of our legend? And I would call this one average speed. And because speed is meters per second, I'm also going to define it here. The second is the color palette. So that one is using option colors. Now here I would like to use HCL colors, which have very nice palettes. And one of them that I would like to use is Plasma, which I used previously on one of the tutorials. I might go for 12 values of Plasma. I know that I have only 6 breaks, but this is gonna actually add more flavor to those streamlines. Here I just define that the name of this palette is Plasma, and I'm gonna take those 12 values. We can also go ahead and define the breaks, which we previously did. So I'm just gonna go here and check once more. Okay, so they're called breaks. But because our breaks have decimal values, I want to round them. I don't want any decimal values. So I'm just going to put here round breaks 0. All right, then we can go ahead and define the transparency levels, because you remember that's one of the things that we define as the main aesthetics. So here I can choose a range. Range here goes for 0, which basically means full transparency, to 1, which means no transparency. So what I would like to do with the range, I would like to offer a broad range, which would go probably from 0.2 to 1. So on the high end, they're not going to be so transparent, so to say. And finally, we can also define scale line width, which is going to measure again, how thick are they going to be, So within the scale line width, we can again use this range argument, but this time I'm actually going to go for twice a smaller value. So I'm going to go for, let's say 0.1 to 0.5, because if you choose very high values here, actually your lines are not going to be that visible. They're going to essentially turn simply into raster, which you don't want to. So this is one part of the customization. Of course, another one that we can add here, you do remember that we loaded Europe and Asia together, so that would be actually huge, but we only want that area of Europe that we previously defined. So we can manipulate that in chord SF. And first of all, we can here put what is the coordinates reference system. So it's WGS84. And then we can define here X limits and Y limits. So here we need to pass here. We already created, so we want them to go from X minimum to X maximum. And also here, for this Y lim, we want from Y minimum to Y maximum. And this is how you define the limits. We can also customize a bit our legend, and for that we use guides. Now, within guides, you can customize the legend for each of these elements, but I find it kind of useful only to do that for the color. So because I don't want to do this for alpha, I'm just going to say that alpha equals none. And I'm also going to say here line width also equals none. But for the color, I would like to define it. So I'm going to say color equals, and then I want to have a binned legend. So for binned legend, I need to go here for guide color bar. All right. And then here I can specify several things. For example, I would like my legend to be horizontal. That's the first thing. The second thing is I can also define, what is going to be the key height or key width. Maybe that's not so important. But one thing that I can do is I can say I want my title to be positioned at the top. Also, I want my legend labels to be positioned at the bottom. So I want them to be below that legend bar. There are other things. You can also here horizontally justify your title. So you can also determine how is that going to look like. So we can, for example, justify it in the middle. You can also justify your labels. So you can use the same arguments. And you can actually put them you can left justify them. You can also say here that the number of rows equals 1. So those are all the options that you can do to customize your legend using guides. After this, we can go ahead and finally define the theme. So one of the things that I want to do here, I want to say that the theme is going to be void. So the theme is going to be simply devoid of any additional things. But for any additional theme customization, I can simply open this one and say theme. And here, there are several things I want to do. First of all, I want to define where my legend is going to be actually located. So for that, you can use legend position. And over here, you can pass two arguments. So the one is X value. So I would actually like it to be in the upper right corner. So that means that both X and Y values need to be high. 0.85 and let's say 1.01. So it's going to be in the extreme right-hand corner of the screen. But I can also specify some other thing. Let's say I can specify legend title size. This one is the text, so you need to tell your ggplots that you're dealing with element text here. And then you can pass to it things like, for example, size, let's say 11 pixels. You can also specify the color. You can say that it's going to be white color. And you can also specify, apart from this, other things. You can also specify legend text. So I'm just gonna, copy this part of code, and the legend text can be like, let's say, smaller. Let's say I also want to have title, so I can also do that. So I can do here plot title, and I can make, for example, title much bigger. I can make it, let's say, 16. I can also, let's say, put it, because I put legend in the upper right corner, I can put into the upper left corner this plot title. So I can just put here 0, which is going to be left justified, or maybe 0.1 just to leave a bit more space. And then I can also push it a bit more towards the map. For that, I can choose, for example, that the vertical justification is going to be -1. Apart from the title, I can also arrange a subtitle if I have a subtitle, and we will have, but I can choose it to be smaller. Let's say I'm going to use a subtitle here to declare my data source. So I'm going to create a much smaller, font size here, but I can also create or actually redefine both the horizontal and vertical justification if I see that fits. I also mentioned that I would like the background of this plots to be dark, and I can also define that using this plot background. But here, because we're dealing with rectangular shape, you need to tell also ggplot2 that this is the type of the object. And then I would like to fill this with, let's say, black, right? And the color, we don't need to color the edges, so that one can be left as is. And finally, in this map, I would like to shrink any space that there is there around Europe. So for that, I can use plot.margin and then define the units that I want to, change. So the first one is the top. For the top, I'm just going to leave it at 0, but everything else, so the right-hand side, I'm going to shrink it, including the bottom side, and finally also the left-hand side, I'm also going to shrink that as well. And then the last thing here, I'm just going to say that the units are lines, but you can also use other types of units. So this is the theme. It's a bit longer chunk, but I think it's useful because it is going to help us make our map better. And finally, we can simply define the title, subtitle using a labs option in ggplot2. Title, or any other thing you can define here. You also caption, for example. So you simply say title equals to, and then within the string you can put, we can, for example, say wind speed on 30th, or actually, sorry, 29th of July 2023. And then for the subtitle, which is going to be actually our caption, in a way, we can just simply copy and paste this from the climate change services. So climate change service, and then the name of the dataset that we're going to use. Anything else that you don't want to be, let's say, don't want to have any value, you can just simply leave like this, for example. So this is the way to leave just empty space if you don't want to populate these things. And here it is, ladies and gentlemen, the wind speed map of Europe for 29th of July 2023. We can see some very strong winds around Ireland and Britain, as well as something around Greece. I don't know what actually is going on there, but anyways, so what we can see here, we can see clearly the average speed. We also here see the value, added value of, getting those different thickness levels as well as the transparency levels, so that we actually put more accent into those, faster winds. Of course, there's a lot of, things that we can change here. If you want to, let's say, accentuate wind streamlines even more, or for example, if you want to bring to light these national boundaries, but I really wanted to put into the front these wind streamlines and also the wind speed. All right, that was all for today, folks. In today's tutorial, you learned how to create pretty and effective wind streamline maps using the data from the European Center for Medium Range Weather Forecast, and all that in R. In today's tutorial, we created one such map for Europe, and if you would like to replicate this analysis, have a look at the description below, where I provide the link to the GitHub repo. I'm really looking forward to you exploring this further and taking this tutorial on a journey across the world. And on that journey, if you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X, or former Twitter. Also, if you're new to R and you seek to expand your knowledge of data visualization and geospatial analysis with R, I prepared a few very useful tutorials for you, so check them out. See you next time.